I do have a question about programs and stuff. So do you think that C should be the first program that we use or
Yeah.
that we learn?
Right. That's up-to-date software
What
we
kind?
using all the time. And most of company using that software.
C++?
Right.
Are there any others in addition to that?
No. Only thing is instead you solving the electronic program, you have to do calculation. And C++ will be helping you.
Okay, thank you.
Yeah, instead you have to do calculation. You will be tell the computer do for you.
Oh, that's wonderful.
Right.
I'll
And
learn it tomorrow.
Yeah. And also that you using all the time.
Oh, okay.
You do whatever else, not electronic, okay, not in this class. However, on a different area, they using that software. Okay, so okay, so today will be start with the operational amplifier. Okay, last time we already know the differential amplifier inside. Okay, and now input go to the negative. That's what the name inverting input. And the input go to the positive. The name is non-inverting. Okay, what is the VD? VD, that's a differential voltage input. They will be equal Vs positive minus Vs negative. Okay? And what the differential input VD equal V positive minus E negative. And they want that have to be equal 0. That will be telling you one thing. V in positive equal V in negative. That's a very, very basic. And you have to know. Okay? Let's see. 3 terminal inverting input minus sign. Okay? Non-inverting input plus sign. And output. 2 power supply. Normally, they can be using positive and a negative from minus to 38. If you're using 15 volt, then minus 15 volt. If you're using 10 volt, minus will be 10 volt. Ideal op-amp. Open loop gain. AOL, that open loop gain. They said equal infinity. Now, when you go to buy the op-amp, this is the op-amp. Manufacturer, they given you open loop gain. Normally equal to 100,000. That means very, very big. Input impedance. That means in here, you get the input resistance equal infinity. Very big. That's only telling you one thing. The current cannot go into op-amp. The thing is they get a big impedance. Okay? Big resistance. Output impedance. That means you can get the resistance right here. That's what they call output impedance. If you want the more current coming in or coming out, then the output impedance they want it to be 0. Okay? So everything when you're looking into operation amplifier, that's a basic thing you have to know. Okay? If you get any question, just bring it up. Okay? We can help you out. Okay, you see this is IC you're working in on the left volt 741 op-amp. They get pin number 1, 4 up to pin number 8. Okay, they will be telling you which one will be input positive, output negative, input negative, and output of the op-amp. Which pin will be positive? Pin 4 will be connected to negative power supply. Pin 7 positive power supply. Okay. Practical op-amp, high voltage gain, AV. Very high input impedance, very low output impedance. They want a wide bandwidth. Okay. Practical op-amp, output voltage Vout equal Vs in at positive minus V in at negative. Okay. Time the gain. The gain they can be open loop gain. They can be low loop gain. VD, difference between two inputs. That means V at positive minus V at negative. The gain open loop gain of 741 op-amp low to 200,000. Output of op-amp is never higher than the power supply voltage. So you see if you're using the plus or minus 15 volt power supply, then the output of the op-amp can not be higher than plus or minus 15 volt. even they get open loop gain 200,000. When input apply is too high, that force the op amp into what we call saturation. When they be saturated, they cannot using the gain anymore. Okay? And the op amp output will be equal plus or minus saturation voltage. That will be telling you normally saturation voltage will be less than power supply, about 1.4 volt. Open loop gain is defined as amplified output amplification without any external feedback signal connect to it. And for a typical operational amplifier is about 100 decibel at DC. That means 0 hertz. Okay? This is a summary for you to keep reading over and over. Okay? Now we try to see if we can do this example. An op amp had open loop gain AOL 200,000 with a power supply plus 15 and minus 15 volt. Given a saturation voltage, that means plus or minus 15. It's supposed to be less than 1.4 volt, but we don't want to make more calculation. So we can using saturation voltage op amp almost the same with the power supply. Complete VD and VO in the following table. Okay, you calculate telling me what the first VD here. You know VD, right? VD equal V positive V negative. So first one, what VD equal? Positive 20 microvolt, negative 40 microvolt.
Negative,
VD,
negative 20 microvolt?
exactly. 20. And they know what the V out. Okay, let's see. I can show you this one. That is VD. Okay, in the middle here, 0 volt. Okay, and now the maximum V plus saturation. That means in this one, 15 volt. On the other side, you can get V minus saturation minus 15 volt. Okay? So, if the voltage difference Okay? Higher than minus 15 volt, less than 15 volt. You want the V out equal VD time V different time A L
No.
L.
Okay.
Okay? Now, you get minus 20 volt, microvolt. What we out? Who get it?
300, negative or positive? Am I correct?
Okay, I understand that. If the VD okay,
0.
okay, if a VD higher than minus 15 volt or less than plus 15 volt. If you want to calculate the V out, you get a VD time the gate. Otherwise, they can be saturated. And now, in here, V out will be
200,000 times the answer that the young lady gave.
okay, VD time AOL. So, who get the out?
Minus 20 times 200,000.
So it's negative 4 million.
Negative 4 volt.
Oh, okay.
Okay, now you do for number 2 for me.
And so minus the plus. It's 60, 70. So VD would be 70. Because 10 minus a minus 60, minus a minus is a plus. So 60 plus 10 is 70. And then it's times 200,000.
And what you get?
$14.
Okay. Now, try number 3. What we did for number 3.
Yeah, minus 50 and a minus 30, so that's minus the plus. So is it minus 20?
Yeah.
BD is minus 20.
So did I make a mistake on the first one? Is it actually 60?
Now, you take 20.
Okay.
You minus 40.
Okay.
That's why you get minus 20.
Okay.
And that will be minus 4, right?
Yes.
Okay, number 4.
BD should be 140.
Exactly.
And then you take that answer,
28.
multiply it times 200,000.
So 28 volts.
Okay. Is it 140, right?
Mm-hmm.
Times 200,000.
Right.
Equal. What equal?
28?
28. What we out?
28.
No.
28.
Wrong?
28 mean here. Alright?
Oh, that's right. Oh,
They higher than saturation voltage.
right. So it's 15.
Oh, yeah. So you
Then
use
the op amp saturated.
Be darned. Okay.
So, Mr.
You-
Pham, when it's higher than 15 or lower than the negative 15, that's what you use, right?
Yeah, they saturated.
Right.
So they have to be equal saturation voltage. They cannot be higher than saturation
Yeah,
voltage.
28 is higher than 15.
Right. So you said now, op amp already saturated. Next one, number 5.
Negative 55.
What we did,
Negative 55.
you take a minus 100 minus 245.
Yeah, but isn't it minus? Oh, I'm sorry. Okay, never mind. It's negative 55.
Negative 100
Oh,
for-
145. Okay.
and what V out?
Let's see. 15 volts, I'm sure. Oops. Yeah, it's 15.
So you check 145.
Negative 15 volts.
Perfect. That's what I want.
Hey, Mr. Pham, on number 5, so basically, under the column where it says input negative, if you just see a number there, that's a negative 45, right?
Negative 145.
Yeah, well, I know you got a negative 100 under the plus column, but under the input minus column, the 45 is automatically negative, correct?
Yeah, the thing is you minus. You take a minus 100. Minus V negative, that means 45. Given to minus
That's
one.
minus a minus 40. Well,
No. How come you get a minus? They positive.
Yeah, 40. I did the same thing, and
They positive.
yeah, it's a positive number, which
yeah,
is
it's
interesting.
positive.
It's yeah,
That's right. Negative and a positive is a negative. That's right.
right.
Now, number 6.
Okay. The 55.
65. Perfect.
Oh yeah, 65.
What output?
Let's see. I think it's 15. Let's see. Oh, no, actually, no, wait.
So you got 65 microvolts, excuse me,
It's
times
13.
20,000.
13.
Perfect. Number 7.
Okay, let's. It's a negative 100.
Negative 100. Perfect.
Yeah, because number 5 and number 7 are pretty much like the same. They got negatives.
So that would be 15. Because it's actually it's over.
Yeah, Mr. Pham, that's oh, I gotta do it that way.
Okay. The last, number 8.
Negative 40. And it's negative 8 volts VO.
Now you know how to do it.
Thank you.
Yeah. So you don't have any problem with the assignment. If you know how to get through this calculation. So basically, this is a very, very basic Okay? You have to know. Okay, now let's see. The operation amplifier. Input signal mode. Single-ended mode. Input applied to either positive or negative of the op-amp, and the other input connected to the ground. That's what they call a single-ended mode. You apply one input, the other input ground, either positive or negative. Okay? Differential mode to opposite polarity. That means our phase signal are applied to the input. So now they want to apply both input, okay? However, make sure you have to understand the input have to be opposite. Positive, negative, negative, positive. Okay? Common mode. Two signal voltage of the same phase, same frequency, same amplitude are applied to the inputs when equal input signal are applied to both input, they cancel, resulting output will be 0. That means if two inputs identical applied to positive and negative, they cannot go to the output. They consider to be the noise. That means the unwanted signal. Op-amp will try to stop, not allow it go to the output. Input offset voltage. The ideal op-amp produce 0 volt out for 0 volt in. Normally you get the input 0 volt. Output supposed to be 0. However, that not really happen that way. That's why they're talking about offset voltage. Okay? In practical op-amp. However, a small DC voltage Vout error appear at the output when no differential input voltage is applied. Its primary cause is a slightly mismatch of the base at middle voltage of the differential amplified input state up and op-amp. Okay, as specified on op-amp datasheet, the input offset voltage VOS is the differential DC voltage required between the input to force the output to 0 volt. Now I try to explain to you. Okay, you can see the op-amp here. Okay, input positive, output negative. Normally, if you get a 0 volt here, 0 volt positive, output supposed to be 0. That's what you want. However, when you measure input 0 here, output 0 here, input positive, out input negative, both 0. However, when you measure the output, they not 0. They can be 100 millivolt. That's what we're talking about, offset output. Okay? Now, in order to make sure whatever you get input here 0, output supposed to be 0. So that's why they get the potentiometer. That's what. Okay? And you connect exactly like that one. And you try to adjust the output up to 0. Okay? That's what they're talking about. Adjust for the 0 volt output. Adjust the offset voltage. Connect the port to pin 1 and 5. Connect both input to the op-amp route. Now, adjust the port until Vout closes to 0. That you will be working on the left volt. Okay? So, this is coming out from the left volt. Make sure when you need to offset the output to be 0, that's what you have to follow the instruction.
Okay, thank you.
Open loop and closed loop amplifier. This is the open loop. You get input positive, input negative, and that's Vout. So AOL, remember, AOL open loop gain equal Vout divided to V in. Now, can you tell me what V in equal? V in here not equal V positive, not equal V negative. V in here means differential voltage. So V in this case, the difference between V at positive minus V at negative. Okay? In the book, they just say V in. However, if you don't have a basic understanding, you don't know what is the V in. V in, that means the difference between V positive and V at negative. Okay? So the gain AOL equal V out divide to V in. That means divide to V at positive minus V at negative. Now, we deal with the one resistor here. Connect from output back into input. That's what they call a feedback. Feedback means output connect back into the input. Okay? Closed loop given configuration. Okay? Inverted. So the gain equal ACL. CL means closed loop gain equal minus RF over RE. However, we will go to that one later. I just bring it up to you. That means this is a closed loop. This is a different no connection back to the input. Okay? By the way, input here, that will be VD. Okay, VD, that means the difference between V positive minus V negative, and VD, V1 equal 0. Remember, very important. If VD equals 0, that's telling you one thing. V add positive, same thing. V add negative. Okay, V is positive now in connected to the ground. So basically 0 volt. So what is the voltage here? What the voltage at this point?
Is that 0 as well, Mr. Pham?
0. Same thing, right?
Right.
V positive 0, then V negative 0. So at this point here,
Is that the virtual ground?
exactly, 0 volt. However, this point is not correctly connected directly to the ground, but it's 0. So they get a different name. They call a virtual ground. What that means? Virtual ground. That means they could not connect to the ground. However, they 0. Okay? However, this one here, they connect to the ground. What's the name? If they connect to the ground.
Is that like earth ground?
Yeah, it's a ground, but I want to know the name. Try to understand separately between this ground 0 volt and this ground 0 volt. This is not connected to the ground directly. That's what they get the name virtual ground.
So then the one where the arrow is at in the bottom, that's like what you call true ground, right?
You have to say that one.
Oh, physical ground. I see what you mean, yeah.
Physical ground.
Because it's physically connected to ground.
Exactly. That means you have to using the wire connect to the ground. That's what they call physical ground. And this one is not connect direct to the ground, but the 0. They call a virtual ground. Try to separate it. Try to understand that. If you get any question, anything, just let me know. Okay, try to understand this, the display here. First thing, you see this is frequency domain. Okay? Frequency will be in hertz. Okay? So, look like 0 here. 0 hertz, 10 hertz. Okay? 1 hertz, 10 hertz, 100 hertz, 1000 hertz. Okay? And so on. and this will be the gate. A, that means the gate. Okay? So, at this point here, minus 3 dB. Minus 3 dB, what is it here? We call a cutoff. Cutoff frequency. If you're looking into the display, at cutoff point here, what frequency equal?
10,
You're going down.
right, it's equal to 10,
10. Okay? 10 hertz.
10 hertz.
So, also they will be telling you the bandwidth will be from 0 up to cutoff. That's what we call a bandwidth. So basically, bandwidth only 10 hertz, you cannot do anything.
Hey, Mr. Pham,
Yeah.
so the bandwidth in this case would be 10 as well, right?
Yeah, will be 10 hertz.
Mm-hmm,
You see right here.
mm-hmm.
What they call a critical frequency. Okay?
Mm-hmm.
So basically, if you on this one here, and you know the gain 100 decibel in dB. Okay? However, the bandwidth will be very, very small. Now, if I want more than bandwidth higher, I say I want this one. What the bandwidth?
Bandwidth is 1,000,
Yeah.
Perfect.
10 to
1000.
the 3.
Okay. And now the gain will be
60
60 decibel.
decibel.
Okay? 60 decibel. Yeah, that tells me you really understand. So basically, one thing they're telling you, if you want wider bandwidth, that means you have to reduce the gain. Okay? On this one, you can see the bandwidth now higher than 10 power 5 hertz. However, the gain only 20
Decibels.
decibels.
So then the gain and the frequencies is inversely proportional.
Right, if you want wider bandwidth, then the gain must be lower.
One go up, one go down.
Exactly. And now, this point right here, they call it unity gain. Okay? And basically, look like 1 megahertz. And you go into the lab, they will be 0 dB. That means the gain equal to what? That's what they call unity gain. The thing is, I try to make sure you can understand. Before I work at the university, I cannot understand. Okay? So, look like you are okay to me. Okay, first one, inverting operation amplifier. When you're looking into the circuitry of amp, you have to know this is an inverting amplifier or non-inverting or amplify, differential amplify, summing amplify. By looking into the circuitry, we're able to recognize. Now, this is the inverting. Inverting, that means your input here connect to negative. That's inverting. If the input connect to positive, the circuitry will be non-inverting amplifier. Now, first thing we're working with the inverting amplifier. So basically you see the current coming in. Go to this point. This what they call a virtual earth summing point or virtual graph. Okay? That means what the voltage at this point?
0.
Perfect. 0. They not direct connect to the ground like this guy. That's what they call a virtual graph. Okay. Now try to see. You get a current input coming in. This current I, first thing, they can go in here. They can go down here. They can go up here. See how they go. First thing, do they go into op-amp?
No,
No.
because
Why?
it's a high impedance.
Higher, very high impedance. Okay, so this cannot go. Okay, next, can they going down?
No,
Why?
because there's no connection there.
No. That's
Because
not
it can't go into the amplifier and come out.
okay, first thing, they not go inside op-amp.
Right.
High
Right.
impedance. Second thing, why they not going down here? I can tell you. You know it's not going down. I tell you why. This is a 0 volt. This is a 0 volt at the same voltage. Current cannot flow. Correct?
Right.
If you get 5 volt, 5 volt, current flowing here will be 0. Correct?
Right.
Current cannot flow through the same potential voltage. Okay? So they're not going down. Okay, so they have to be going up. They're going up here. First thing I know, when the current coming in, positive, leaving, negative. So that's why that will be telling you that will be negative voltage. That will be positive voltage. Okay? So this current go to this point. Where they go? Go in the op-amp, going down. Which one?
Positive.
I want to know this current I here.
Oh,
Where-
that current's negative, right?
This current positive, right? They go through the resistor. Can they coming in positive, leaving negative? So the current will be flowing down. They can be go this way. they can go this way. First thing, my question is, this current can go this way or not?
No,
No. How? Why?
there's no way for it to go that way.
No. Yeah.
Because you have zero ground?
But the thing is, current must be flow from positive to negative, not flowing negative to positive. Okay?
Mm,
So when I already prove for you, this is negative here, this is just a wire, so this is negative. So when the current's going to this point, they cannot going down. The thing is, output negative and the other side must be positive. So they cannot going down.
So you're saying it's got to go inside the op amp?
Exactly.
mhm.
So it can go, the current can go go in the op amp from the output in, but not from the input out.
Right. So that's what they call a sync current. Sync current means op amp will be pull the current in. Okay? And that current here, we call I out. Now, this is a positive, this is a negative. Also, you get the current flow this way. That's what they call IL. That means the load current. Finally, in this case, I op amp equal current I plus I L. That means current I means the current go to RF. Current IL means the current go to the load. RF means feedback resistor. They connect output to the input. Okay, let's see what they tell you. RF feedback resistor between output and inverting input produce closed loop gain ACL. No current flow into the input terminal. High input impedance. That means we're talking about current go in op amp. The different input is zero. Vd equal V1 minus V2. That means V1 equal V2. So finally, closed loop gain ACL equal minus RF divide RE. Okay? So you want to calculate the gain. You take the minus RF divide RE. That is basically for inverting amplifier. Okay? Now, on that one, we see. You see that? I already explained everything to you. Okay? Current coming in, not here, not down here. They go up here. Coming in, positive, leaving, negative. Okay, and this current go to this point. They cannot going down. They go in. And also another IL. That load current. When they go up here, they cannot go up here. They have to be coming in. That's what we talking about I/O, output of amp current, equal current I plus IL. Now, try to see what they try to explain to you here. Current I equal V in divide R1. If you want to calculate this current, you understand this is the route. You get 1 voltage here, 1 resistor, and this is the route. Law. You take V in divide R1. You get the current I. In this case, 5 milliamp. And now you want to calculate the closed loop gain. ACL equal minus RF divide R1. That given to you minus 1.5. And now, if you want to calculate the V out equal voltage gain times V in minus 1.5 times 5 volt input here, you get minus 7.5 volt. This is what we call an inverted amplifier. That means input positive, output will be negative. If the input negative, then output will be positive. That's what they call an inverted. Load current. If you want to calculate the current, you take the V out divide to the load. This is more calculation telling you, okay, you can get 1.5 milliamp. Finally, if you want to calculate the current of amp, adding up, okay, that means you can get 6.5 milliamp. That's all the calculation for inverting amplifier. Okay, summarize. When you're looking into op-amp circuitry, you must recognize this is the inverting amplifier. Okay? What is the gain? Okay? And how do we calculate the current? Current I and the current low. Then you want the op-amp current, add them up. Any question for inverting amplifier? If you see the picture, you can understand whatever. So you hear, okay? That means you really understand for inverting amplifier.
So the formula for load current is IL equals 0 minus V out over RL or RL.
You're talking about IL,
Yeah,
right?
yeah.
I show you.
Okay.
IL.
0.
Okay? Basically, V out to calculate, let's see. V out equal minus 7.5, right?
Right.
Okay? So, if you say VL divide to 5K, you get minus, correct? If you apply Ohm law, okay, IL equal VL divide RL. And you say minus 7.5 divide 5K. Then you get minus 1.5 milliamp. You see that?
Yep.
Okay, now you understand that the current cannot be negative. They have to be positive. Then I telling you, IL, that means the voltage different here, right? Divide RL. So you have to calculate the voltage different here. One side they get 0 volt. The other side you get minus 7.5 volt. So they supposed to be equal 0 minus 7.5. So that's why you get 7.5 divide IL. So that's why you can get positive current. Not negative. If you calculate this way, you get negative current. Okay? Current cannot be negative. They have to be positive. It is show you how they get to the positive. Normally, this is more detailed to prove current is positive. If you're doing this way, okay, but the answer have to be 1.5 milliamp, not minus 1.5.
Okay.
Okay?
Yeah.
Now, this coming out from level. Do it for me. This is the inverting amplifier. Okay? Try to see you can get the correct answer. Go working through 1, 2, 3, 4, 5. If you get the correct answer from 1 to 5, that telling me you really understand. And you will be see that when you're doing level.
So the gain would be -10?
I don't know. Keep going.
Oh, okay.
Yeah, I think you get the right answer.
Wrong?
Correct. Yeah.
Data point. Oh.
You know the formula VL, right?
Mm-hmm.
What VL?
10. Oh, I'm sorry. Give me a second. Is it 10 volts? 10 volts?
What the gain? What is the gain?
I got -10, and then I thought
Oh.
I thought it might be -1.0.
You take the gain, time input,
And the input's 1.
input 1. What the gain?
-10.
So what VL?
-10.
Perfect.
Okay.
Okay. Now they want the current I through this R2. That means the current here.
Right. Okay, so that's been divided by R1.
Now, remember, they want current here, right?
Mm-hmm.
This is 1 volt.
Right.
This is 0, right?
I mean, then by, yeah, R2. So it'd be 1 divided by 1 kilo. 1 kilo ohms. So it's 1.
Is it right?
Yeah,
1 milliamp.
1 milliamp.
Okay. Go ahead with IL.
IL. One.
IL equal. Perfect.
No.
What is the op-amp current?
1 plus. 1 plus 1
Yeah, perfect.
is 2. 2 milliamps.
You made million. Good. So, yeah, it's telling me I really happy that I can understand what's going on. Any question about this example? Okay, let's see. Okay, now you try to finish this example for me. Now the input will be 1.2 V peak to peak. They're telling you AC signal at frequency 1 kilohertz. First thing they want closed loop gate.
Okay.
You understand?
3. -3.
Perfect. Yeah, you're doing very good.
Thank you.
They want V out.
Okay. That's 1.2. -3.6.
Perfect. However, the answer will be 3.
Oh, sorry.
Why?
Huh?
Why 3.6? We calculate have to be minor.
Yeah, it has to be minus because
Yeah. However, you understand AC, the peak to peak. If you put negative, that's okay. Just telling you, input, output, our phase. Okay?
okay.
The answer will be minus 3.6 volt peak to peak. However, AC, you cannot say positive or negative. Minus 3.6 just telling you input output will be our phase. That means input going up, output going down. They just opposite. Okay? Colon I to R1.
Eight milliamp, 0.8 milliamps.
Perfect. 0.8.
Cool.
Okay?
Mhm.
So, they telling you, not here, input, output is inverted, or 180 degree out phase. Okay, any question on this example? You see that part here, right? That telling you they zero, but they not connect directly to the ground. And they're telling you virtual route.
Right. Oh, boy.
Aha. Now, okay, we'll try to finish to help you to understand this circuit. And we will stop, okay?
Okay.
The thing is, I don't know, I get about 8 students, and I saw more students working on the level in the program. If they not in the lecture, how come they understand? And that's how come they can pass through the final test. Okay? If it not get through the final test, then they cannot go to Tech 2. Now, this circuitry, you see the difference. They call a non-inverting amplifier. That means the input applied to positive. That's what they call a non-inverting. If the input applied to the negative, then that is inverting. We just done. Now we'll see what happened. They say AL equal 1 plus RF divide R1. Okay, first thing. We see what's going on here. 5 volt here. The input right here. That in V in. So what V in equal? You understand is that's just a voltage divider. So V in equal 5 times R3 divide R2 plus R3. Okay? So they already explained to you here. V in equal V1 times R3 divide R2 plus R3, 2.5 volt. That means right here. That is the V in. Okay? Okay, not this one. Have to be right at the positive. V in. Okay, now my question is, I want to know the voltage here. Who telling me what voltage here?
2.5.
2.5. Perfect.
Because those two nodes where the double arrow is going, VD is equal to V plus minus V minus.
Okay, now you can see the voltage from here to here. Okay? That means the difference between here, they will be
The same.
0. That means the voltage here and voltage here the same. 2.5 then have to be 2.5. The thing is, no voltage drop here. So when you get a 2.5 volt here, and this is the ground, you can calculate the current. Okay? I here. Law. 2.5 divide 1K. 2.5 milliamp. Okay?
Mr. Pham, I got a question.
Yeah.
You say that, where that node at, or where that arrow is going both ways, you got, VD equals V plus minus V minus equals 0. Now, where Vn is at, that's 2 volts.
V in 2.5.
Okay, right. I mean, 2.5, excuse me. And electrically, the minus on the op amp, the minus terminal goes up to where that big red dot is at. So that's 2.5 as well, right?
Right.
But you said that, and this is a non-inverting, so the input's
You're
going
talking about here, right?
Yeah, right there. I'm wondering why isn't that, it's 2.5 there electrically, isn't it?
Now, the thing is, you understand the voltage from here to here.
Well, you got a wire connected there, though.
You don't have any wire.
No. The big red dot on top, all the way down to the minus on the op amp, that's
Yeah.
a wire.
However, from here to here is 0. Is it correct? From here to here, 0.
Correct.
And that means here or here will be the same. Right?
Okay.
Wire. So that's telling you, you get 2.5 here, then you get 2.5 here.
Mhm.
Okay.
You cannot hear 2.5, no. Okay? The thing is, basically, this just they're telling you.
Oh, is that because that's virtual ground?
No. They're just telling you. Okay? VD, difference between here and here is 0. Okay? So now you can say here 2.5, that's okay. But this is just a wire. We don't care here. We care on this point. At this point here,
The
2.5
VD, so
volts.
you're saying the VD is only between the minus and the plus.
Right. Right here.
Right.
The difference 0. Correct?
Correct.
So they're telling you this is just a wire. So the same thing. The difference between this point or this point, same thing, 0.
Okay.
So this point to point 5, and they have a no difference, then this point will be same thing.
Okay.
Okay. So you get 2.5, you get a round. So you can calculate the current I. Okay. Now we're talking about current I. Where this current coming from? First thing, cannot current here,
Mm-mm.
No, no.
right?
Right,
Right.
Same potential.
right.
No. So this current I at this point must be coming from here. Okay? So the current basically they will be go this way. Positive, negative here. And this current I will be coming here. Okay, how do we get this current? Okay? The thing is right now, Vout will be positive, negative. My question is, how come you get positive?
Because up there on the feedback resistor side, one side is negative, one side is positive. The
Right
positive,
here.
yeah, that positive goes all the way.
Positive and just a wire. So
Right,
that's
so,
why you get positive.
right, so you got positive there.
Yeah.
So therefore, the other side is ground, which
Right.
is negative.
So this current cannot coming from here. They must be coming out from up air. In this case, they say source current. Remember, in the path, we get current going in. That's what we call a sink current.
Current.
And this current basically coming out from the op amp. That's what they call a source current.
And Mr. Pham, also you said your current has got to go plus to minus, not minus to plus, right?
Yeah, they go from plus to minus.
So that's why it's got to be going down. It can't go minus to plus.
Exactly.
Okay.
So basically, if you're looking here, I out of the op amp equal IL plus IL. I plus IL. So they given everything for you here. Okay? So the gain. Now if you want to calculate the gain, okay, of the op amp, first thing, they equal 1. Okay? Plus RF over R1. If you want to calculate the V out will be measured from here to here, or from here to here. So basically, V out will be equal to voltage across RF plus the voltage across R1.
Don't V out equal the voltage from across RL?
Now, I tell you first thing. V out can be, okay, RF time current I. That means the voltage here. Plug the voltage here. Plug R1 times I. Okay? Or they can be I times R1 that V out. Okay? And let's see. V out. They explain to you here. V out equal IL times RL. Okay? Second thing, V out equal VRF plus VR1. That means we already telling you right here. VRF. This one. VR1. Okay? And V out equal I. Okay? Time RF plus I time R1. And I will be V in divide to R1. We already telling you right here. So, finally, this is the formula. V out equal V in times 1 plus RF divide R1. And this given you the gain. The gain equal V out divide to V in. Okay? If you get the V in, okay, and you get the V out, then you can get the formula 1 plus RF divide to R1. That only telling you one thing. The gain on the way greater than 1. The thing is 1 plus RF divide to R1. Okay? So anyway, we will be stopping the guy almost saturated. Cannot.
Mr. Pham, basically pretty much a yes or no answer. See where you got V out at on the schematic?
Be out here.
Yeah. So if you put your black probe at ground and put the red probe there, would you get a true V out reading?
If you want to measure V out,
Right.
the next high side here,
Connect high side where the yellow is at.
the high side here,
Yeah, right.
low side drop.
Right.
Or you can connect V out high side here, low side drop. Same thing.
And you get the same thing.
Exactly.
Okay, thank you. Thank you. Thank you.
Thank you.
Okay, so anyway, we'll be stopping. Okay? I
Okay.
hope this time we don't have a problem with echo, right?
Yeah, no problem.
So that's why you will be seeing the meeting today on the web. I will be uploading.
Okay, thank you.
Okay, so hope everyone will have a good weekend. Okay?
Thank you, Mr. Pham. Thank you.
Thank you, Mr. Pham.
Thank
Okay,
you.
we'll see you next
Thank you.
time.
Have a nice week.